Okay, good morning students. This is the second class of digital communication system. Uh, okay, today we discuss the pulse code modulation technique. Okay, so first of all, uh, last class we discussed that about the basics of the digital communication, etc., etc. Okay, now one important thing is that our real life is analog. So if our real life is analog, so how we converted that analog signal to the digital signal? That is the very important point. Now, so this pulse code modulation. This is a method by which we convert a analog signal to a digital signal. Okay, the how? The question is how. For that, first we describe the block diagram of the transmitter as well as receiver of the pulse code modulation system. So first of all, why it is called pulse code, etc., etc., that we describe the next class. Okay, so first block, that is called LPF or low pass filter. Okay, so why we used here low pass filter? Because we know in our basically in our audio signal, that is 20 to 20 kilohertz, basically this is the LP low frequency signal. So that's mean in our daily life for hearable purpose we use the signal that is very low frequency. So for such type of criteria we used here the LPF system, that is low pass filter system. That's mean if there are any higher term of frequency, that filter discard that higher term of frequency and only use the low frequency signal. Okay, after that we passes that low frequency signal a specific block diagram that is called sampler. Okay, the sampler, that particular word comes from the term sampling. Okay, sampling means one type of chopping. Suppose we have a slice, we have a bread, and if we chop that bread, then that bread becomes some slide of the bread. Okay, so sampler means this type of circuit by which we can sample the signal along the x-axis. Okay, next we go to the quantizer. Here the quantization process is very critical. So basically in one word we not describe the word quantization, but if we go very short term, quantization means one type of approximation, and after that we used here the encoder. Okay, encoder means there are some form we convert the from one form to another form. Okay, so this is the transmitter of the PCM system. After that we used here the regenerative repeater. Okay, so what's the function of the regenerative repeater? This is a big issue. And next, if we go in the receiver portion, so this is the PCM input, then we use regenerative repeater, then decoder, then reconstruction filter, and then destination. Okay, so before starting that block diagram we go for descriptive analysis. Okay, so first of all, this is our analog signal. We suppose we use that signal and we want to convert that signal in the digital signal. Okay, this is the analog signal. Okay, so first of all we passes that signal through that low pass filter. Okay, very fine. That's mean after low pass filter only low frequency contents here. After that, that frequency passes through a sampler. Okay, as per my previous talks, the sampling means this is a process by which a signal is chopped along x-axis. So this is that process. This is the x-axis t. This is an interval t, t0, then t1 dot 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 dot, dot t in. That's been in that position, in that position, in that position. We chop the signal in that way. Okay, so that is the sampling process. Okay, after sampling process we go to the quantization process. Okay, now this is very important. What do you mean by quantization process? Okay, the first of all, always remember quantization means rounded off. Okay, so first of all, this is my sampling signal. Okay, now this is my y-axis or amplitude axis. Now we sample that signal again along this. Actually sample, that word is not suitable here very properly, that otherwise we say that yes, sample along y-axis. In that way we assume there are from here to here there are L number of interval, okay, and our maximum limit here MP and minimum limit here minus MP, okay, and if we consider each interval is del V, okay, then del V means MP minus of minus MP by L, that's mean 2 MP by L. This is called the del V, that's mean size of the one interval. Now what do you mean by the quantized signal or quantization process? So first of all, suppose we consider that particular portion, we assume this is 0, assume this is 1, this is 2, this is 3, this is 4, this is 5. Now suppose this is the t0 position. Now t0 position, amplitude of the system, that is just exceed the 0, 1 to 3 point. So we assume that t0 position, my amplitude is 3.1. Next, this is t1 position. Now t1 position, my amplitude is 1, 2, 3, 4, 5. In between 4 and 5, when it is tends to 5, so we assume in t1 position my amplitude is 4.7. This approximation, okay, obviously here fold, okay. Next we assume another position, that is t2 position. Now in t2 position the amplitude is 1, 2, 3, 4, 5, 6. In between 6 and 7, okay, so 6 and 7, and obviously it is 1, 2, 3, 4, 5, 6, near tends to 6, not tends to 7. That's when t3 we assume 6.3. Now we told you that the quantization means rounded off. That's mean in that particular process, suppose we go in the t0 position, in t0 position 3.1. 3.1 means it is tends to 3, okay, just 3.1, that is tends to 3 it is. That's mean by the help of that quantization process, this particular sample rounded off to the 3 amplitude, okay. Next, this is t1. If we go in the t1, that is 4.7, okay, 4.7 means that is near about 5, that is more than 4.5, okay. So if we go in the 4.5, that's mean it is tends to 5. Next, if we go in the t3, then it is 6.3. 6.3 means it is lower than 6.5, that's mean this is tends to 6, not tends to 7. Okay, now so if we summarize that quantization process, that's mean from t0 position we got the number that is 3, then t1 position we got the number that is 5, and t3 position we got the number or amplitude that is 6. Next step after the quantization, that is called the encoder. Okay, so what's the function of that encoder? Okay, as per digital electronic circuit or digital concept, encoder means this is the circuit which convert one form to another form of the signal. One form means obviously this is digitized form. So here that is 3, 5, 10, that is not the binary condition. And always remember, in digital communication system we use the number as a binary condition, okay, because 0 and 1, because we need only 2 level of the signal, okay. So first of all 3 means, okay, so if we go for the 3, then 3 means 0, 1, 1 to the power 0 to the power 1 to the power, okay. So that is the 3, that is the encoded version of the 3. Next, if we go in the 5, encoded version of the 5, that's mean to the power 0, 1, 2, 1, 0, 1. Similarly, if we go in the encoded version of the 6, that is 1, 1, 0. Okay, so that's mean in that way, in the quantization process, there are t0 to tn sample. So each sample after rounded off process or quantization process, we got some value like approximation that value, and after rounded off process, and after the encoding version, so we got the this kind of number, that is 0, 1, 1, 1, 0, 1, 1, 1, 0. That's mean end of the day, if we transmit, if we consider the input as a this type of analog signal. End of the day we got the output like that. That's mean for this particular condition 0 1 1, next for particular sample 1 0 1, next sample 1 1 0, etc etc etc. In that way a huge number of bit stream. Okay, so this is the process by which we convert analog signal to the digital signal. Okay, and second thing is that this is the transmitter portion and this is the channel. In that channel we use some term or block that is called regenerative repeater. So about regenerative repeater we described in later hugely, but now a little bit about the regenerative repeater. So what do you mean by regenerative repeater? Okay, there are so many processes from here to here. If we transmit it from low pass filter to sampler, then quantizer, then encoder, so end of the day we use the signal or in binary number, that is the 0 1 again 1 then 0 then 1 then 0, in that way. But the signal is looks like that due to some noise or distortion, etc etc. Okay, and obviously if we go in the amplitude level, then that amplitude level obviously minimized. Okay, so regenerative repeater is a process by which we can remove that particular type of disturbanceness, as well as we enhance my amplitude level as my desired level. That's the basic function of the regenerative repeater. And about regenerative repeater we describe in the specific class. Okay, after regenerative repeater, here this is the receiver portion. This is the, again we use the regenerative repeater circuit, because if we use the more and more regenerative repeater circuit, then my obviously input or output, whatever, that means this type of signal becomes too much smoother. After that, here we used a decoder circuit. Okay, so decoder means this is the encoder. That's mean if there are 0 1 1 1 0 0 in this type of bit stream, that we, by the help of the decoder circuit, we converted the bit stream in the another conversion. That's mean that 0 1 1 means 3, again 1 0 1 means 5, again 1 1 0 means 6, in that way. And after decoder, we, that's mean by the help of the decoder, it the signal converted to a again that previous level, that's mean 3 5 6, in that way. Okay, and after that we use here the reconstruction filter. Basically here we use the reconstruction filter, means if there are 3 there are 4 5 6, etc etc. So end of the day, if we connect the signal becomes too much distorted. Okay, and there may be some noise and distortion. By the help of that reconstruction filter, we remove that particular type of unwanted waveform shape, and after that we throw the signal to my proper destination. So that's mean by the help of the transmitter circuit, we convert the signal from analog to digital process, analog part to digital part. Then after that, here we use the channel. Okay, by channel we repair or prepare the signal for next step, and then we use the receiver circuit. In that receiver circuit, basically here the signal, that particular type of signal, converted in the digital form to analog form. So this is the very simple analysis of the pulse code modulation technique, and next class we describe very elaborately the pulse code modulation technique. Okay.